Hello and welcome to the new class of the transient analysis. We are here to analyze the transient. New class of transient analysis. And what is our today's agenda? Today's agenda is to analyze one RC circuit. We will analyze transient for what? Transient for RC circuit. So how we can analyze one RC circuit? Let's take one example. And as I said, we will analyze everything without any shortcut, just by the basics. So what I have told you that voltage across capacitor do not change abruptly. So VC0 minus is always equivalent to VC0 plus. C represents the capacitor. One more thing I have told you, IL0 minus is always equivalent to IL0 plus. The current across capacitor, the current across inductor and the voltage across capacitor cannot change abruptly. These are two things. One more thing is what? The solution of the differential equation dxt divided by dt plus p times of xt equal to q is given by xt equal to e to the power minus of pt into integral of e to the power pt into q into dt plus k into e to the power minus of pt. So this is the whole story we have talked yesterday. Now let's analyze the RC circuit now. And we have seen what are the time constants, and we have seen the theory of time constants also. So time required by, and I have described the two definition of time constant, one for discharging waveform and another for charging waveform. So time constant represents this represents speed of the response. This represents speed of the response, and yesterday we have detailed discussion on the time constant. Let's take the first example today, and this example is we are having one circuit. This is RC circuit, so I am taking this is some V naught voltage, this is R. What else is given here? One resistance is given. What else is given from here? Here one capacitor is given. One capacitor is given and one RC is also given. A wonderful question. This is R1. This value is C2. This value is C1. What else they are saying? The here a switch is connected here. So let me draw a switch at this point. Switch is going from point A to point B. Let me say this is point A and this is point B. Switch is going from point A to point B, and they are asking about the current in this loop IT for t greater than 0. We are interested in IT for t greater than or equal to 0. This is our question, and this is the first example I am taking. This is the first example I am taking on the RC circuit. So what I can say, I have to analyze this circuit for in the range of minus infinite to plus infinite. I have to analyze this circuit from in the range of minus infinite to plus infinite. So let me draw the duration. Minus infinite to plus infinite is the range for which we are analyzing the circuit. If we are analyzing the circuit from minus infinite to plus infinite, so remember one thing. This is the point where t is equivalent to 0. This is the point where t is equivalent to minus infinity. And let me draw one more point where t is equivalent to 0 minus. As I have told you yesterday that my intention is to only comment on the IT for t greater than 0. जो मेरा इंटेंशन है वो IT के करंट के t greater than 0 के वैल्यू पे कमेंट करने का है, लेकिन I can copy the voltage from T0 minus to T0 plus, else I don't need this T0 plus and T0 minus. So we are interested in the calculating voltage at this point. VC0 minus. What is VC0 minus? Because your circuit is started from t equal to minus infinity, if circuit is started from t equal to minus infinity, if circuit is started from t equal to minus infinity, can I say at t equal to minus infinity, the circuit will looks like this. A voltage source, a resistor, And do you know that t equal to 0 minus is a steady state point, because we know that every circuit is having a steady state values, means at t equal to 0 minus our circuit has achieved the steady state, means circuit is starting from t equal to minus infinity. So how your circuit will behave in steady state? Your energy storing element is capacitor, and capacitor behaves open circuit in the steady state, correct? So if I say this voltage is V naught, what is this potential drop? This potential drop is 0, because there is no current in the open loop, so potential drop is 0. So you can say the value of Vc 0 minus is equivalent to what? V naught. So Vc 0 minus value is given by V naught. And what I want to say, that suppose I am writing the differential equation for t greater than 0, then I can copy this value from here to here. This is the only thing I want to do, that value at Vc0 plus is also given by V naught. Yes or no? If this is okay to you, the only need, we have only requirement of this analysis only to calculate only to get the value at Vc0 plus. Else I don't need this circuit for t less than 0. Means if this questioner will give me the initial condition of the capacitor, then I don't need to analyze the circuit for t less than 0. So let's go for the next. Let's analyze the circuit for t greater than 0. So can I say t greater than 0 circuit will looks like this? We are having one capacitor, and the we are having one capacitor, and what else we are having? One capacitor C1, and take care of the polarity also. Then we are having one resistance R1, and then we are having one capacitor C2. C2. Again, very interesting thing is, what is very interesting thing? Very interesting thing about this circuit is, we are having two energy storing element, out of which one is having initial condition and one do not have any initial condition. So can I say C1 has initial condition, while C2 has zero initial condition. C2 has zero initial condition. So let's say we are taking one current I, because I am interested in the current IT. And if you are interested in the current IT, you need to write the KCL. So what is KCL? The KCL analysis is given by, the better way is to write KVL. Kirchhoff's voltage law will be the good choice for analysis of this circuit. Although you can analyze by any mean. So this is what KCL, the voltage across capacitor C1. So this is 1 by C1 integral of IT dt plus IT into R, and plus we are having 1 by C2 integral of IT into dt, because current in all elements are same. So we have applied one KVL. I hope everyone is aware with the KVL. So can I say this is intro differential equation. So let's differentiate it. So can I say, when I differentiate it, 1 divided by C1 plus 1 divided by C2, because when you differentiate this, this is IT divided by C1 and C2. You can write this times of IT plus DIT divided by DT into R is equivalent to 0. Into R is equivalent to 0. And when I write the homogeneous differential equation, how it looks like? It looks like this. 1 by C1 plus 1 by C2 into 1 divided by R into IT plus DIT divided by DT equal to 0. Now we can write the direct answer, because this is homogeneous differential equation, or 1 upon C1 plus 1 upon C2. I can write 1 upon C1 plus 1 upon C2. I am writing this value as 1 divided by C equivalent. So I can say the whole equation can be reduced as DIT divided by DT plus 1 divided by R into C equivalent into IT equal to 0. And whenever I say this is a homogeneous differential equation, then what is solution of this equation? Variable separation method can be applied, and you apply the if you apply the variable separation method, the value of IT can be given by k times of e to the power minus t divided by R into C equivalent. Always remember, solution of the differential equation is only valid for t greater than or equal to 0. Solution of the differential equation is only valid for t greater than 0. So when I say what is value of I plus, so I plus can be given by k. But this is the problem. Why this is the problem? This is the problem because we are having capacitor as our energy storing element, and capacitor can store the voltage only. It cannot store the current. If capacitor can store the voltage, I have to draw the circuit at T0 plus to calculate the current. So can I say this circuit I am making for calculating the initial condition? Circuit at T0 plus. This is very important. This circuit is only valid for T0 plus. So can I say capacitor C1 is what? The C1 is having voltage V0 with this polarity plus minus. So I am replacing my capacitor C1. This value is what? V0. Always remember, this solution is not valid for t greater than 0. This solution is having validity only at t equal to 0 plus. Then we are having one resistor R1. So you can say one resistor is there. R, not R1. And what is next? Next we are having capacitor C2. But we know that the initial condition of the capacitor C2 is 0. C2 do not have any initial condition. And if it do not have any initial condition, the voltage stored by that capacitor is equivalent to 0. And 0 voltage is represented by what? 0 voltage is represented by short circuit. So I will say capacitor C2 will replaced by what? Will be replaced by a short circuit. Correct? And I am interested in this current. This current is known as I0 plus. So always remember, if initial condition is given for the voltage, if initial condition is given for the voltage and you are calculating current, then you need to draw the circuit at t0 plus. So you can say the value of I0 plus is given by V naught divided by R. This value is what? V naught divided by R. When I substitute this value here, can I say the value of I0 plus is equivalent to V naught divided by R into e to the power minus t by R into C equivalent. Or let me write it, R into, and this equation is only valid for t greater than or equal to 0. This is very important thing. And this is not I naught plus, this is the value of general current, the current you are having from the circuit. This is the value of, this is the value of IT. So can I say the current across inductor IT can be written as V naught by R into e to the power minus t divided by R into C equivalent for t greater than or equal to 0. When I draw this waveform, how this waveform will looks like? The waveform will looks like this. How this waveform will looks like? Here I am drawing current, here I am drawing time. Differential equation can answer you only for t greater than 0. It will not answer you for t less than 0. Always remember this thing. So can I say the circuit will looks like this? At t equal to 0, what is the value? At t equal to 0, value is V naught divided by R, and after t equal to 0, this will goes to 0. Yes or no? And there is one more important point. That point is known as time required by response to reach 1 by e of its maximum value is known as time constant. So always remember what is time constant. So 1 by e, it will reach at 1 by e when t equal to RC. So you can say this is V naught divided by R into E minus. This point is. So time required by response to reach 1 by E of its maximum value is known as time constant, and this time constant is RC equivalent. So always remember, for RC circuit the time constant is always given by, for a very important point, for RC circuit time constant is given by R into C equivalent, or R into C. R into C is the time constant of the circuit. So what is time constant? Time constant is R into C equivalent. Now I can calculate everything across this capacitor 1, 2 and 3. Let's say, let me draw the circuit and let me analyze the whole circuit. What I want to say, I want to say this. We are having capacitor number 1, we are having capacitor number 1, C1, we are having this, and we are having C2. Now we know that the IT, current IT is given across this. If current IT is given across this, can I say the value of IT is given by V naught divided by R into e to the power minus of t divided by r into c equivalent, and this expression is only valid for t greater than or equal to 0. This is the condition which is we are aware of this condition for this circuit. Now let's analyze the circuit. Let's say I am interested in everything. I am interested, first thing I am interested in, what is the VC2? VC2, or let's say I am interested in VC2 as a function of time. So do you know how to calculate the VC2? The VC2 is given by it is 1 by C to integration of IT dt. And when I integrate this, how integration will looks like? Can I say VC2t is 1 by C2. What is integration of this? I naught is V0 divided by R. And what is differentiation of this? Integration of this, it is minus of R into C equivalent. Correct? Into e to the power minus of t by, I am writing it, this is a tau. What is tau? Tau is a time constant which is represented by R into C equivalent. Correct? So VC and plus one integration constant, that integration constant is K. So you can say VC2t is given by, what is cancelled from here? R and R is cancelled. C equivalent is what? C1 C2 divided by C1 plus C2. So you can say this value will be C1 divided by C1 plus C2. This thing is done into V0 into e to the power minus of t by tau plus k. You can write the voltage and current across every component once you know the any parameter. Either if you are aware with the voltage or if you are aware with the current, you can write any parameter. So you can say VC2t is having this expression. Now you have to tell me what is the VC0 plus, because now we are having integration constant. Let me write this constant as K1. So can I say whenever V2t equal to 0 plus, at 0 plus this value is what? E to the power 0. So this value is C1 divided by C1 plus C2 into V0 plus K1. As we know that there is no initial condition for the capacitor C2. If initial condition for capacitor C2 is 0, means if this is 0 equal to C1 divided by C1 plus C2 into V0 plus K1. So we can find the value of K1 from here, and the value of K1 from here is given by minus of C1 divided by C1 plus C2 into V. And now I can replace this K1, and what is the final answer for VC2? The VC2t is given by C1 divided by C1 plus C2. I can take common. C1 divided by C1 plus C2 into V0. This value I can take common. If I can take common this value, what is answer then? Then answer is 1 minus e to the power minus of t by tau. And this answer is only valid for t greater than or equal to 0. Even if they are not asking this value, but we can develop the understanding that if one variable is known, you don't have to reanalyze the circuit. You can answer the circuit for, so you can say, what is the nature of voltage across V2? The nature of voltage across V2 is this. Nature of voltage across V2 is given by this. Nature of the voltage across V2 is given by this value. And what this value is, if I represent this by T, if I represent this by T, if I represent this by V2T, then can I say at T equal to 0, at T equal to 0, the voltage we are having is minus C1 divided by C1 plus C2 into V0. And when T will approaches to, okay, at T equal to 0, this voltage is 1 minus 1 equal to 0, means VC2 at T equal to 0 plus is what? 0. And when T approaching to infinity, this voltage will reach at which point? This voltage will reach at this point. Minus C1 divided by C1 plus C2 into V0. So how I will draw the graph? I will draw the graph like this. Correct? This is charging of the waveform, but for negative value, but still it is charging waveform. So this is the idea. This is the idea. You can draw V1 IT, we know, V2 VC2 we know. Suppose I want to write the R1. What is R1? So you can say R1 here is nothing but IT into R is VR. Suppose we want to write uh, one more variable here. Let's say this is C1. This is C2 and this is R. Let's say I am saying this value is VR. Then what is value of VR? And that comes from the Ohm's law. This comes from the Ohm's law, because the current in the circuit is IT and IT is known. What is IT? IT is given by 1 by V0 by R into e to the power minus of t by tau for t greater than or equal to 0, and tau is given by R into C equivalent. Then can I say VR is nothing but IT into R. And what is IT into R? R times of IT. And what is IT? V0 divided by R into e to the power minus of t by tau. Means what I want to say, we can write the voltage and current across every component of the circuit, and this value is not what? V0 into e to the power minus of t by tau. Again, solution is valid for t greater than or equal to 0. Correct? Now suppose we are interested in VC1, and how you will write the VC1? Suppose I am telling this is my VC1, then I can write the value of VC1 also. If this value is VC1, you can say, you can use the original formula also, or you can use the KVL also. This potential is given as VC2. So you can say by applying KVL, you can say VC1 minus VR minus VC2 equal to 0. So you can say VC1 equal to VC2 plus VR. And VR we also know, and VC2 we also know, and you can verify the result also. So what is VC1? This is VC1, the voltage across capacitor number 1. So VC1 is given by VR. VC2, what is VC2? Minus of C1 divided by C1 plus C2 into V0 1 minus e to the power minus of t by tau, this much times of v naught into e to the power minus of t by tau. This is the expression. Now we have analyzed everything for t greater than 0. And you can verify also the value of this for t equal to 0 is what? V naught. And t equal to infinite, what is the value? At t equal to infinite, this value is v naught into c1 divided by c1 plus c2. So we can analyze everything using one variable. Even we know the voltage or current, if we are aware of any of the thing, we can analyze the whole circuit. So I hope this analysis is clear, and the analysis is clear, and we can have the waveform across every component. Let's go to our next question. And the next question is, again we are having RC circuit. So this is example number 2 on the RC circuit. We are having example number 2 on the RC circuit. So in this way, this value is R, this value is C2, this value is C1, and switch is initially open and then it will be closed. Now they are calling this value as V1, and they are calling this value as V2, and they are calling this current as IT. What else is given? Remaining all things are given. They are saying that initial condition for C1 and C2 is given. They are calling V1 0 minus, this parameters are given. V1 0 minus is equivalent to 2 volt. V2 0 minus, this parameters are given, is given as 1 volt. V2 0 minus is given as 1 volt. What else is given? The value of capacitor C1 is also given. The value of capacitor C1 is given by 1 farad. The value of capacitor C2 is given by half farad. These things are given, and value of R is given as 1 ohm. Correct. We want to calculate three parameters in this circuit, and these three parameters are V1, V2 and R. We are interested in these three parameters of the circuit. So let's analyze the circuit. Because initial conditions are given, if initial conditions are given, then we don't need to analyze the circuit for t less than 0. This is our agenda. So let's analyze the circuit for t greater than 0. For t greater than 0, how our circuit will looks like? So you can say circuit will looks like this. This value is C1. This value is C2. And what is the value we are having here? This value is R. And let's say I am saying this current is IT. So we are applying one KVL. So if we apply one KVL, can I say 1 divided by C1 integral of IT dt plus IT into R plus 1 divided by C2. 1 divided by C2 is what? The voltage across capacitor. Integration of IT dt. All these three components are connected in the series. If all components are connected in the series, and you can write the voltage across, the current will be same in the all components. If current is the same in all components, can I say if I differentiate this differential equation, can I say this is 1 by C1 1 by C1 plus 1 by C2, 1 by C1 plus 1 by C2 into IT, because we are integrating it, so we are differentiating it, so integration will be cancelled, and plus we are having dit divided by dt into R equal to 0, or you can say dit divided by dt plus 1 divided by R into C equivalent IT equal to 0. And now we can easily find the value of IT. This is which variable equation is used? Homogeneous first order differential equation. Variable separation will be used, and the value of IT is given by k times of e to the power minus of t divided by tau. And whom I am calling the tau? I am calling tau by which way quantity is tau? R into C equivalent. I am calling this as a tau. Now everything is known to us. What is C equivalent? C equivalent is given by C1 C2 divided by C1 plus C2. And what is C1 C2 divided by C1 plus C2? As we know the value of C1 and C2, 1 plus half. So 1 into half divided by 1 plus half is 3 by 2. So this value is what? 1 by 3. C equivalent is 1 by 3. R is 1. So tau equal to what? 1 by 3 second. Tau equal to what? 1 by 3. If tau equal to 1 by 3, I have my whole equation. I of t equal to what? K into e to the power minus of 3t for t greater than or equal to 0. This expression will be very simplified when you go with the numbers. Now we are interested in this constant, and to calculate this constant, because we know that differential equation is only valid for t greater than 0. So to calculate the constant, I need to use the initial condition. If I replace t equal to t0 plus, then what is the equation? The equation will gives you k. Now how to identify this k? Because energy storing elements in the circuit will stores the energy in form of voltage. Energy storing elements of the circuit stores the energy in form of voltage, but we are having current. We want current as initial condition. So let's say how this capacitor and everything is working. Let me draw the circuit at T0 plus. Circuit at T0 plus. And how circuit will looks at T0 plus? Can I say circuit at T0 plus will looks like this? I will replace my capacitor number 1 because initial condition of the capacitor 1 is given as 2 volts. So I will take this potential as a 2 volt. This polarity is already mentioned. How your circuit will looks at resistance will looks like? The resistance will looks like same. This value is also 1. And we are interested in one more value, and that one more value is the initial stored energy of capacitor number 2. and initial stored energy of the capacitor number 2 is 1 volt. Whenever you are having capacitor as energy storing element and you need the voltage, if you need the initial condition for current, or if inductor is available in the circuit and you need initial condition for the voltage, then you have to draw the circuit at T0 plus. This value is 1. Can I say a closed loop circuit is there, a potential difference is there, so you can expect one current from here, and this current is not copied from T0 minus, this is current at T0 plus. So I0 plus is equivalent to what? Higher potential, which is 2 volt, minus lower potential divided by resistance, which is equivalent to 1. So can I say the complete solution for IT is given by what? I0 plus is given by 1 ampere. So you can say this solution is what? K into e to the power minus of 3t for t greater than or equal to 0. Or I can say the value of IT for the circuit is given by e to the power minus of 3t for t greater than or equal to 0, or you can write this by multiplying by ut, unit step function. This is our value of IT. If value of IT is known, we can calculate everything across this circuit. Let's say we are interested in V2T. So what is V2T? V2T is 1 divided by C2. And what is value of C2? The value of C2 in the circuit is 1 by 2 farad. So 1 divided by 2 farad into integration of IT. So integration of e to the power minus 3t into dt. When I calculate this, V2T equal to what? 2 by minus 3 e to the power minus 3t plus the constant of integral, indefinite integral. Let me write this constant as k1. Now we have to find the value of k1. What is k1? So you can say that what is the initial voltage of the capacitor number 2? So initial voltage of the capacitor number 2 is 1 volt. It is already given. We don't need to calculate it. So can I say to calculate the initial condition, we have to calculate this V20 plus. And what is V20 plus? Minus 2 by 3 plus K1. And V20 plus is already given. This value is what? 1 volt. So what is K1? Value of K1? Value of K1 is 1 plus 2 by 3. 1 plus 2 by 3 is equivalent to what? 5 by 3. Now you know the value of V2T also. So you can say the value of V2T in our circuit is given by value of V2T in our circuit is given by 5 by 3 minus of 2 by 3 e to the power minus of 3t. Correct? Here also this is one discharging kind of a charging kind of circuit. So how much it is charging? You can easily say that how much it is charging. How much it is charging? It is charging from, what is the value? If I say this is V2T, if I say this is T, if I am calling this as T, if I am calling this as a V2T, what is the value at T equal to 0? So you can say the value at T equal to 0 is what? The value at T equal to 0 is 1. And what is value at T equal to infinite? When you put T equal to infinite, it will go to 1 to 5 by 3. So this is the charging waveform of capacitor number 2. It is going from 1 to 5 by 3. So only yesterday I have told you, you will have only this kind of charging and discharging equation. Now you know what is the V2T. You can calculate the V1T also by the same principle. If you are interested in V1T, can I say the V1T is given by one by C1 integration of IT dt. What is 1 by C1? The C1 is equivalent to 1 farad. So it is e to the power minus of 3t into dt integration of this plus k2 integration of this. When I calculate the integration of this, can I say the v2 v1t is given by minus of 1 by 3 e to the power minus 3t plus k2. Now how to calculate the initial condition? To calculate the initial condition, we have to calculate the v1 0 plus, and you know that this voltage condition I can copy from 0 minus, so this value is minus 1 by 3 plus k2. v1 0 plus is already given from the question. v1 0 plus is what? 2 volt. So you can write this voltage is 2 volt. So 2 is equivalent to minus 1 by 3 plus k2. So K2 is equivalent to 6 plus 1, 7 by 3. So this value is what? 7 by 3 minus of 1 by 3 into e to the power minus of 3t. This is the voltage across V1. This is V1t. And V1t is also charging from some point to some point. Means at infinity it will reach up to the 7 by 3. And if you tell me, sir, what is the voltage across resistance, that also we can calculate. What is the voltage across resistance? If I call that voltage as VR, the VR is what? 1 into IT. 1 into IT is what? E to the power minus of 3t for t greater than or equal to 0. So this is how we can calculate the everything across the everything across IT, VT, we can calculate everything across every component of the circuit. This is how we can analyze our given circuit. I hope this analysis is clear. Uh, we will we will see few more circuits in which the one component is charging, another component is not charging. We'll see this variety today, and then we will introduce the concept of time constant. Means you can solve the circuit directly by looking at the circuit. You can next line you can write the answer. We will calculate that technique in the next class. Thank you very much.